All right, Chapter 2, Test Review. Let's get right after it. Number 1, we have just a regular old equation here to solve. Looks like we got x's on both sides. So nothing to do on the left. I have 5x plus 7. On the right-hand side, there are some like terms there. I see the 8x and the minus 3x, so that's a 5x. And then I have the positive 3, positive 4, so that's plus 7. Now I noticed something weird. The exact same thing is on the left and the right. And if I were to subtract, the 5x from both sides, I would get here, take 7 away from both sides. Eventually, you'll get down to 0 equals 0, but you don't have to go that far. Once you see that the both sides are equal, that is called the identity. And what that means is that any x you plug in there is going to work. It's always going to be equal to each other regardless of what x is substituted in. So the answer is C, all real numbers. All right, number 2. So I start off just like a normal algebra equation. I'm going to minus this 6x from both sides. And my next line would read 5x take away 6 less than 9. So I'm going to add 6 to both sides. I get 5x, 15. I still have not multiplied or divided by a negative number, so do not flip it. I'm dividing by a positive 5. So again, you leave the sign alone, and I would just have x is less than 3. Correct answer there is C. All right, number 3. I need to do some distributing here, it looks like. So I have 10 subtract 6x less than 15 subtract 6x. So when I add 6x to both sides, it's going to go away. And I'm going to end up with 10 is less than 15. Then I have to ask myself, is that true or false? Since it's true, then we're talking about all real numbers again. If that would have been a false statement, it would have been no solution. All right? So the correct answer here, again, all real numbers. Number 4. So number 4, it looks like we have a proportion. So let's solve this proportion. And the big thing here is I need to make sure to multiply the number by both pieces, kind of distribute them through. So 14x plus 14. I have 22x. Subtract 22. And let's get all my x's over here. I'm going to go negative 14x, negative 14x. So x's are gone from there, which means I need to make my numbers jump over here. I'll combine a few steps there. So then we have 36 equals, what's that, 8x? And divide both sides by 8. And I get 36 over 8, which will also reduce down. 4 goes into those numbers. So if I divide by 4, and divide by 4, I will get 9 over 2. There we go. Top of the next one, we have number 5. So now we're getting into the percents. So these questions here come from section 2.2. So if you're looking in your notes, all these percentage ones comes out of 2.2. So California has the highest state sales tax at 7.25%. Remember, as a decimal, when you move it 2 to the left, you're going to get that as the decimal. Michigan has a 6% sales tax. So remember, that's 0.06. Suppose you're considering buying a car that costs $24,500 before tax. How much more expensive? So that's an important phrase right there. How much more? So you're going to be doing subtraction here. How much more expensive will the car be in California than Michigan? So basically we need to do the California price minus the Michigan price, and that'll tell us, how much more it'll be. Well, the easiest way to do sales tax is like this. So for California, we have $24,500. Now, if you multiply it by 1, that would be no tax. That'd be just paying for the car. But then we have to add another 0.06 or 0.0725 because we're in California. And then the Michigan price would be the car times 1.06, and that's tax everything out the door. The one just makes it to where you can you don't have to add it back in after the fact, finding tax separately. So 24,500 times 1.0725 is 26,276.25 cents. And then 24,500 times 1.06 is 25,970. And now I got to subtract them back out. Looks like $306.25. So California gets an extra $300 that Michigan doesn't in their taxes on that car. Number 6, you buy a pair of shoes for $121.90 after the tax. So this is what you actually paid at the register. What was the original price before the tax? So you always want to set up these equations. You know, you have the original price. And then in Michigan, you're going to multiply it by 1.06, and this will give you the final out-the-door price. Well, we don't know what the original price is, so I'm just going to call it P. We do know the tax in Michigan, 1.06. And then we do know what the final tally was. So it looks like we're just going to divide both sides by 1.06. And the correct answer there is B, $115. Be careful. You can't find 6% of this and then try to subtract it. It won't work because your original 6% was on a lower amount. It was on the price of the shoes, just the sticker price. So you can't apply the 6% at the end and go backwards. You won't make it to the right spot. All right, number 7. 7's a little bit tougher, so this was also this was kind of like the baseball, softball example. So if you're looking through your notes and you're trying to get some help, we had a couple problems involving pitchers and doing feet per second. So the Raven R500 is a crossbow that can shoot 500 feet per second. What is the speed in miles per hour? So right now, I'm at 500 feet in 1 second. And I need to get all the way over here into miles over hours. So we got to kind of take care of some stuff here. So 500 feet in 1 second. Well, it depends on, do you want to get to hours first, or do you want to get to miles first? Let's do the feet first. So if I want to turn feet into miles, I need to set up a conversion. And if feet's on top there for 500, I need to put feet on bottom and miles on top. And there is a conversion. 1 mile is 5,280 feet. And that will allow me to cancel out feet. So now I'm in miles per second. Well, we want to get rid of those. We're good with miles, but we want to get rid of seconds. So since seconds are on bottom, I'm going to put seconds on top. And the conversion I have with seconds is to minutes. So I know that 1 minute is 60 seconds. So those cancel out. And then I'm almost to hours, but not quite. So I then need to say that 1 minute, or actually check that, 60 minutes, because I want hours, is 1 hour. So we're going to get rid of that and get rid of that. And now my only units left are miles per hour. So I just need to multiply. So on the top, I have 500 times 60. And on the bottom, I just have 5280 times a bunch of ones. So I put that in my calculator. I get, what's that? 30,000 miles in 50 to 80 hours. And let's divide those two out. So 30,000 divided by 5280. Punched it in wrong. Now that can't be right. What did I do wrong here? Oh, I forgot. I had two sets of 60s. I had a 60 plus another 60. So that's going to change this top number. So 500 times 60 times 60. Oh, that's a big number. 1, 8, and then 5 zeros. So 1, 8, and divided by 5280. There we go. 340.9 miles per hour. So that arrow is moving, man. 340 miles an hour is pretty doggone fast. All right. Number 8, the manager at Eddie Bauer has a jacket that sells for $160. So that's what the price tag is, $160. So there's my starting price. Put it on sale for 20% off. So if I want to do 20% off, I got to do 1 minus 0.20. So that means I'm paying 80% of full price. Now, after that, we apply another discount, another 25% off. So 1 minus 0.25, which means I'm paying 75% of that new price. And then it says, what is the sale price before tax? So whatever this is, that's going to be the sale price. And let's just crank it out. 160 times 0.80 times 0.75 is $96. Okay. Point to know here is that when you apply two different discounts, you cannot add them together. You can't somehow try to do 45% because the two percentages are on new sticker prices, different prices there. All right, number 9 says write an equation in slope-intercept form. So we know that's y equals mx plus b. And I got to go through those 2 points. Well, graphing's not going to be very smart here because it goes way up to 27, plus it takes longer. So whenever I want to graph a line, I got to do the slope and I got to do the point. So let's do the slope first. It's y minus y. So that's 15. And x subtract x on the bottom, which would be 3. So it looks like it's 5. So remember, it's change in y over the change in x. So my slope is 5. So now I write my starter equation. Y equals 5x plus, and then I don't know the y-intercept. So we have to solve for b. And what we're going to do is we're going to plug in either point, whichever one we want. I'm going to plug in the 3 and the 12. So I'm going to go back here, and I'm going to plug in the 3 right there, and the 12 right here. And I'm going to get 12 equals 5 times 3 plus b. 12 is 15 plus b. So it looks like b is a negative 3. So then I can go back up to my equation there, and I can say, hey, man, you're not plus b, you are minus 3. Whoop, minus 3. And there we go. There's my equation in slope-intercept form. All right, number 10. So number 10, slope-intercept form just means I have to solve it for y, get y by itself. So I'm going to move that 4x to the other side and make it opposite, make it negative in this case. Then I have to divide by 2, everybody. So I get a negative 2x plus 4. U are the same exact line as u. just now you're in slope-intercept form, which means I could enter you into a graphing calculator, which is always helpful. Check yourself sometimes. All right, number 11, write the equation of a line with a given slope and passes through a point. So we go straight to our starter equation. I know the slope, but I do not know the b. That's what we're after. So just like last time, put the y in, put that x in, and start solving away. So 3 equals 3/2 times 1 plus b. So 3 equals 3/2 plus b. You could minus 3/2 from both sides. You could also right now just times by 2. Clear that fraction out if you want to. 6 equals 3 plus 2b. Minus 3 minus 3. And then divide both sides by 2. And you'll get b equals 3/2. So now you can go back to your starter equation. And you can plug in there plus 3/2. And there you go. You got your equation that fulfills the given criteria. All right, number 12. Let's see what we got here. Write the equation of a line that passes through a point and is parallel to 3/2 x plus 9. So first thing that's important is I need to be able to look at this line and I need to know that, okay, you're the slope of this line. And my line, all right, my line needs to be parallel to that. So if it needs to be parallel, that means I got to keep the slope the same. So I'm going to start writing my equation. My equation is y equals, keep the slope the same. We do not know b. So, but I have a point to pick through, so I have an x and a y. Let's jam it in there. And I get -2 equals, that's 12 divided by 2, which is 6. Minus 6 minus 6. So it looks like b is -8. So now I can come back up to my starter equation, and I can put a -8 in there. And hopefully I did all my math right. All right, number 13. Bunch of these. Write the equation of a line, equation of a line. This one, though, says perpendicular. So I need to do the opposite reciprocal of this slope. So my starter equation is going to be a little different. It's going to be the opposite, meaning if that one's positive, I got to be negative. And then it's got to be the reciprocal. Again, I have an x and a y. Let's jam those in there. And now we got to get after it. So -2 equals -8/3 plus b. Now I could add 8/3 to both sides. Maybe I'll show it that way this time. And I could multiply everybody by 3 and clear it. But maybe I'm like, I feel like adding fractions. I don't know why I drew it like that. That looks kind of goofy. But I'm going to add 8/3. But I can't add -2 and 8/3. I need to write this in thirds. So if I do -2 times 3, that's -6/3. So -6/3 and a positive 8/3. Looks like b is going to equal 2/3. So I go back to here, put plus 2/3 in there. And there we go. Life is good. All right, looks like we're getting into SAT world here for number 14. Slope of a line. A line has a slope of 2, goes through a certain point. Graph of a second line goes through 2 points. And then they intersect at some unknown point. And then once you get those 2 coordinates, subtract them. There's 2 ways to do this. I'm not going to show the algebra way because it's really long. But basically, you'd have to write 2 algebra equations and then set them equal to each other. So, you would write the equation. Let's just call this the blue line. You'd write that equation. So you'd have the blue equation. Y equals blah, blah, blah. Well, then you'd do your second line, and you'd have to write an equation for that. You'd have to find the slope, starter equation, plug it in, and then you'd have a red equation. And then you could solve those two to find the right x, to find the x part of the intersection. I think that's a long, drawn-out way. So I want you to get practice at sketching your own graph and making it somewhat accurate. So I'm looking at points here. It looks like 6 is the biggest. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And on the SAT, you really want to try to keep these spaced properly so that you see relationships right. So the first one, it goes through the point -1, 4. And then a slope of -2 means go down to right 1, down to right 1, down to right 1, down to right 1, down to, and go up the other way. So hopefully that's enough dots to get where we need to go. My next line has to go through those points. 2, 4, over 2, up 4, and over 4, up 6. So it looks like that one is dropping 2 and 2, or 1 and 1. Bam, right there. So I just found that intersection. You're going here, you're going there, and I found the infamous AB that they're looking for. Well, it's really 0, 2. That's the A and the B, 0, 2. So they want me to do what's 0, take away 2. The answer would be -2. All right, number 15, this one didn't show up too good with teacher made because I had a little trouble with the matching. But you want to kind of think about your quadrants. And remember, we said it kind of makes a C. So 1, 2, 3, and 4. And let's look at the different scenarios here. So I'm going to do multiple lines on this one just to make it easier. So my first line has to go through quadrants 1, 2, and 3. Well, the only way to go through 1, 2, and 3 would be something like that. And that is a positive line. Remember, positive lines go up and to the right. So this one is positive. The next one we'll do in blue. If I got to go through 1, 3, and 4, 1, 3, and 4. So that looks like it would have to be down here. And 1, 3, and 4 is also going to be positive. I'll do this one in green. 1, 2, and 4. So to cut through 1, 2, and 4 only, I think we'd have to stay up in this area, which would be a -1. So I'll just put a little N there. Then I'll do this one in black. 2, 3, and 4. 2, 3, and 4, it looks like I'm going to have to stay down here. So that's going to be negative. Then maybe I'll do red dotted line. Red dotted line for 2 and 3. Well, 2 and 3 means I'm staying over here, so I'm vertical. So that would be undefined. And then I'll do a blue dotted line, 1 and 4. Oh, that would be over here. So it looks like that one is also undefined. Looks like I didn't put any 0 ones in there. So maybe I could have kind of written this question backwards a little bit. I could have said, hey, which one would be a 0? You know, when does 0 happen? Well, 0 would happen if maybe I was just in quadrants 1 and 2 only. That might be, because 1 and 2 would have to go that way. So that'd be 0. All right, next problem, number 16. Before I do anything else with standard form, So I need to find the slope of this line because it says in the xy plane, the graph of which of the following is parallel. So I want to be parallel to this guy. All right. I don't know his slope yet. His slope is not equal to -2. Okay, just because you're in front of an x doesn't mean you're a slope. That's only if you're in slope-intercept form. So one way to do this problem would be to resolve it for slope-intercept form, get y by itself. So I would add the 2x to the other side and make it positive. And then I would divide everybody by 4. And I would get y equals 1/2 x plus 3/2. And now I can see the slope. Now I'm like, oh, the slope's really 1/2. Now, a couple times I've showed you guys that there's a shortcut. The slope is always the opposite of a over b. And in standard form, the number in front of the x is the a, and the number in front of the y is the b. So you're always doing the opposite of a over b. All right, so anyway, parallel was 1/3. So I'm looking through here to see if I can find any, or 1/2, I mean. If I can find anybody else with a slope or a half, we're in good shape. So let's do this. So remember, this is my A column, this is my B column. So opposite of A over B, well, that's -1/2. Opposite of A over B, hey, there's a 1/2. This one, opposite over B, there's another 1/2. I screwed this one up. Opposite of A over B, -1/3. Nope. So there were actually 2 correct answers. I think on Teacher Made, I only made the correct answer B. So I apologize, but that one I'd have to accept 2 right answers. It happens. Number 17. What do we got to do here? Same question, but we need to be perpendicular. So first of all, let's figure out the slope of the line given. Opposite of A over B. Sweet. Now, for me to be perpendicular, my slope has got to be the reciprocal, and it needs to be positive. So I'm looking to see where a positive 3/4 is. Well, for part A, opposite of A over B, man, it looks like I got it. Because this one is opposite of A over B, no. Opposite of A over B, no. Opposite A over B, no. So it looks like the correct answer there is A. Number 18, graph that expression there. Hard to graph because it's in standard form. So let's repackage it. Let's move the 6x to the other side and make it the opposite. And let's divide everybody by 3. And we get -2x plus 5. That one's not too bad. So put my grid on here. All right, so first thing I'm going to do is I'm going to go to my y-intercept. So I'm going to count 1, 2, 3, 4, 5. That's the y-intercept. And then this is my slope, which means I need to go, you can kind of think of it as -2 over 1. So I got to go down 2, right 1. Down 2, right 1. 2 and 1, 2 and 1, 2 and 1, 2 and 1. Done. All right. This one's friendly. It is in slope-intercept form for me. So I'm pretty sweet here. I'm already decked out. I got a cross at +3. And then my slope is negative. I got to go down 1, right 2. Down 1, right 2, down 1, right 2, down 1, right 2. And something like that. All right. What values of k make the equation have no solution? Well, first of all, you got to ask yourself, well, when does that happen? No solution happens when you end up with no variables and you end up with something like, 2 equals 5 or something. Anytime you can get a false statement, but I need to get my my coefficients in front of x to be the same. So this side is 2x minus 15. This side would be 2 times kx plus 6. So basically I need to get these two to be equal to each other so I can cancel them out. So it looks like if k equals 3, I'd have 2 times 3. You know, if this would have been a 3 in here, that would have been 6x minus 15 and 6x plus 6. And then when I cancel these out, I would have a false statement of negative 15 equals 6. And that would give me no solution. So k had to be 3. Solve and graph this inequality. So let's kind of go through this. So I just solve it straight up. I don't know, maybe this time I'll minus 4x from both sides. So that'll be negative 3x added to 8 is greater than or equal to 17. I'll minus the 8 from both sides. Now I'm going to divide by a negative 3, divide by a negative 3. Oh crap, when you divide by a negative, flip the sign. So x has to be smaller than negative 3. So here's that. X has to be less than or equal to. So it's because of this bar right here, I got to shade that in. And then I just want to test something, like, I don't know, let's stick negative 5 in, see if it works. So is a negative 5 plus 8, how does that compare to 4 times negative 5 plus 17? Well, this is 3, and this is negative 20 plus 17, and that's a true statement. So it looks like negative 5 worked, so I believe everything over there is going to work. You know, if you try negative 4, it should work. It'll just stop working anytime you're to the right of negative 3. All right, so I have that. Now I think I need to do interval notation. So let's kind of just talk about the two types of notation. So we had this. So it looks like my answer is, when I think about the boundaries here, the right boundary is negative 3, the left boundary is negative infinity. I think in Teacher Made, I just had to write out INF for infinity. But I don't know these things yet. Infinity always has the soft parenthesis bracket. When you have the greater than or equal or less than or equal, you're going to have a hard bracket. All right? If it's an open circle, you have a soft bracket. But if it's a closed circle, you're going to have hard brackets. And then set builder notation was, so I had earlier that x had to be less than or equal to negative 3. Set builder notation, you just say the set such x is such that. So this is kind of a fancy way of showing set builder notation. All right, I believe that's it. Hopefully that helps you out and gets you ready for the Chapter 2 test. See you.